We're going back for round two. Let me get the chat up on here. All right. I think wait, are we back?
So you are going to share the screen first, right? After that, you need to give the sharing to me.
Yeah, exactly. Exactly that. Right. Okay, we are streaming, apparently. So things are good. Right, okay. What's going on, guys? Stoic here. Sorry about that little hiccup. Basically, there was a big Mac OS update yesterday, right? Last night. And so it messed with all my system preferences. So I had to quit to re-enable all my system preferences. So hopefully you can actually see and hear what's going on now. I can't tell anymore because I don't have the chat. But it says we're live, so I can only assume that that is the case. Okay, so we're going to start off. In this video, we're going to be doing, this is the final workshop that we got before the hackathon. So we've covered a ton of stuff about VeChain specifically. But this week, in this final workshop, we've actually got a guest with us from Wanchain called Weja. And Weja, sorry if I've mispronounced that name, it's very difficult for me. I'm Welsh, aren't I? So pronunciation's not good in the best of times. But we've got basically one of the engineering team from Wanchain to talk us through a bunch of the different tooling. But before that, I just want to spend a few moments reminding you guys about what's going on with the hackathon, get everyone in the mood, and then we're going to dive straight into all the interoperability stuff. So hopefully this works this time. Okay, I think it is. I think it is. All right, guys. So this is the Wanchain workshop. And we're going to be talking a lot about interoperability. And as I've already mentioned, we've got someone from Wanchain to walk us through all of their tooling in person, which I'm really looking forward to. If I can hit the next slide. A quick little about the hackathon before we get started. The hackathon's starting next Monday, and it's going to be running for 2 weeks. We're looking for team members of 2 to 4 as a size. And obviously it's online. Anyone in the community or any other developers or other blockchain engineers are more than welcome to get involved. There's a prize pool that's spread over 3 tracks of 30K USD, which is rewarded in either VET tokens or USD, depending on the participating team's preferences. Now, cool. I kind of want to run through this really fast. So there are 3 focus areas or 3 tracks for the hackathon. The first one is social impact, which is building for people. The second one, economic and environmental impact, which is protecting our planet. And the third one is ecosystem and technical innovation. This is growth for the VeChain ecosystem. And this is where our interoperability track basically resides. So if you're interested in building interoperability or cross-chain tooling, we're going to be using Wanchain's infrastructure to build some interesting and innovative solutions on VeChain. Okay. And all right, cool. So that's it. Enough of the spiel. If you guys have any questions or anything in the chat, just pop it in the chat. I'm going to be monitoring it. And whilst I keep track of you guys and kind of relay any questions that we got going for the Wanchain team, I'm going to pass it over and introduce to you Weja from Wanchain.
Yeah, thank you, Luis. Let me share my screen first.
Yeah, absolutely.
Yeah, actually, I just sent the request to authorize my sharing.
I've just authorized it for you.
Okay, cool. Okay, can you see the shared screen?
Yes, I can. Yep.
Okay, cool. Yeah, hi. Well, thank you for joining this seminar. My name is Weijia Zhang, and Luis pronounced my name very well, actually. I'm VP of Engineering of Wanchain. We do interoperability for cross-chain transactions, and today I'm going to introduce a lot of cross-chain interoperability technology to you. Before this meeting, I was asking Luis about my audience, and we said that most of you are developers and you want to know about how to build a cross-chain application, what are the development environment, what kind of tools we have, and what kind of libraries and things, the process that you need to follow. I think this is exactly on the right track that I have prepared. Actually, I'm an engineer myself, and I actually teach and write books also. This is my book. It's called Blockchain and Ethereum Smart Contract Solution Development. Okay, this is almost 500 pages document, and so I'm going to touch a lot of programming details because Reese tell me that most of you are developers. So, but I'll be focusing on the interoperability. So I'm going to just go through these things and help you decide your hackathon topic and also help you develop the hackathon project for VeChain. So let's continue. Okay, so today's presentation is about using XPort for cross-chain messaging for this hackathon. And XPort is a product of Wanchain to have a framework for cross-chain interoperability. And we believe that cross-chain has 3 layers. First layer is the messaging layer. Second layer is the remote function call. And third layer is the applications. If we build the framework of messaging for you, then the developers should be easily be able to implement application on top of it. And these will be the cross-chain application, which means that you build one smart contract for one blockchain, and that last smart contract be used by all the other blockchains. So that'll be great. It's just like a run once and applicable to all chains. You don't need to write smart contracts for every chain. So that is the goal of cross-chain interoperability. And I think Luis had mentioned that already. Wanchain and VeChain, okay, we are partners. Okay, so we announced the new partnership news a couple of months ago, and basically we just want to bridge VeChain with all the other blockchains, and actually Wanchain build that bridge. Okay, so you should be able to bring a lot of assets from other blockchains to VeChain and vice versa. So if the asset, this cross-chain asset, is like make asset to be chain or agnostic, you should be able to use asset in different chains, and this called asset cross-chain. So we have that infrastructure already. So this is the VeChain with Wanchain working together to open pathway to new possibilities. It's just not just confined in VeChain. It can be applied to all the other blockchains, not just EVM, not EVM as well. So today we're going to expand that. That is a bridge built by Wanchain. And today we actually want to introduce XPort, which is a framework for connectivity. And you should be able to leverage XPort to build your own cross-chain application. So that would be great. So you have a full control of cross-chain interoperability through our XPort infrastructure that we built for you. And this XPort has been implemented, deployed to TESTNET or VeChain already. So you should be able to use it for your hackathon project. Actually, I tried it yesterday. It worked very well. So I tried that for you already. And actually, our engineer actually fixed one issue yesterday. So the current version is the latest one. So content, first of all, cross-chain. I believe most of you are familiar with developing smart contract for one chain, for one single chain. But I have not seen a lot of developers who are familiar with cross-chain applications, which means that you have one smart contract in one blockchain talking to smart contract on another blockchain. That is still kind of classified as a kind of complex domain. So not many people know about that. But today I'm going to show you how do you do that, and actually very, very easy when you have the infrastructure ready, like XPort. So we're going to talk about cross-chain, and then talk about cross-chain technologies, and talk about the messaging SDK, which is the XPort that we have. And then we're going to build, discussing how you can build the hackathon project. And there'll be a lot of high level, but more on the technical details as well. But because this is a kind of a very compact subject. If you kind of lose track of it, you can send a message to Luis, and so that I can explain further. Okay, and there are resources I'm going to share with you. You can always come to GitHub to look at the examples and look at the SDK. It should be easy. Yeah. Okay, so hackathon description with Wanchain XPort. Okay, it's just to explore the world of cross-chain applications with Wanchain XPort. And XPort, as I explained, it is the infrastructure for messaging protocol across different blockchains. Okay, so you should be able to build a decentralized application that operates seamlessly between VeChain blockchain and at least one other EVM compatible blockchains. Okay, so I want you to be able to, I encourage you to be able to build a cross-chain applications where you can transfer token in VeChain to Ethereum chain, from VeChain to Wanchain, okay, or build an NFT token that reside on VeChain and let people who have Ether to buy it. Okay, we have that technology, and you should be able to build that application easily in this hackathon. Okay. Let me go for the. So what is cross-chain? Okay. When you talk about cross-chain, you have two chains, at least two chains. You have a salt chain and hux chain. And then cross-chain is a protocol or a set of protocols, frameworks, or platforms to facilitate the transfer of assets, messages, data, or commands among blockchains. So it's very important. Most of you are familiar with transfer asset. Okay, you can wrap BTC to Ethereum and become WBTC, and that is asset transfer. You let the asset reside on Bitcoin blockchain, by actually have a mirrored asset on Ethereum blockchain. And the reason for doing that is when you have BTC native with Bitcoin, there's no DeFi in Bitcoin blockchain. So there's not much you can do to become a storage of assets. But when you bridge that BTC to Ethereum, when it becomes WBTC, that is the ERC20 token, then you can use this WBTC for lending, for exchanges, for application, all kinds of things. So kind of unleash the power of Bitcoin, which is normally a storage, a store of value. So that is asset transfer. And second thing is the message transfer, which means that you have something happen in one blockchain, and then you can detect the message and then put that message on the target chain. So you can do event transfer. So that the event kind of talking to each other. And also data transfer, you have some data in one source chain, and then you can, that data be accessible to other blockchains. And the one example is the credential, right? That diploma or birth certificate. You don't need to put the birth certificate or diploma or some kind of proof in every blockchain. You just need to put in one blockchain and all the other blockchain to access it. And then the last one is command blockchain, which is you should be able to issue command from source chain onto another chain to call the smart contract on the target chain. And this is almost like a remote execution across different blockchains, and they'll be more difficult. Okay, and in fact, XPort has that kind of capability already. So I'm going to explain that further. Okay, I hope you are kind of following my thought here and my presentation here. But if you have any question, let me know. I can go back a bit, explain more. And this is a kind of a higher diagram overview of what we are doing. On the left-hand side, it shows that this is one bridge that we connect with different blockchains. We connect Bitcoin with Ethereum, with Cardano, with Polygon, with enterprise blockchains. And then we also connect with Wanchain, and we have VeChain connecting together with Wanchain's bridge. And then once you have these chains connected, you can build the cross-chain DeFi, right? You can build the wallets, cross-chain wallets, payment system exchanges, decentralized exchanges, which is cross-chain, and also do settlement, and then we do loan, cross-chain loans, lending, etc. And your hackathon project will be on the right-hand side, which means that you want to build cross-chain decentralized applications. And then when we go further, you're going to say, hey, it's very easy. I have those tools already. So we have built those frameworks for you already. In fact, it will be so easy after this presentation, after you look at our example, you say, aha, this is so easy. How come I did not know it before? Okay, so yeah, this is kind of another different views. We have bridge, and then we have a DeFi connecting with layer 1, and layer 1 to layer 1, layer 2 to layer 2, and also layer 1 to with layer 2 as well. And then on top of that is a set of application layers. And this is the same as the previous diagram. It's just in the different view angle. Yeah, and then the core chain mechanism. Okay, how do you do core chain? What is the mechanism for core chain? Okay, so first one is what I call lock and mint, and then burn and unlock. So I call it LMBU. Lock and mint means that when you have a native asset in a native chain, you can lock it with a smart contract, then nobody can change it. And when you lock it, you can then emit an event saying that, hey, this amount of asset have been locked by the smart contract. And then you can mint the same value of the token on the target chain. And then because the native token has been locked, then the mirror token become the active one. Then you can start using the active token on the target chain for exchanges, for transfer, for DeFi applications. So that's lock and mint. Okay, so when you build a decentralized application, you need to know this mechanism. When you say cross-chain, you are actually locking and then burning. Right? You are not kind of destroying the one on the, you are not destroying and then create. You are just locking, then mint. And then when you want to kind of transfer the token back, you need to have burn and then unlock, because you need to destroy the mirror one on the target chain and then reclaim the lock one. So you just burn on the target chain and then reclaim the token on the source chain. So this is the LMBU mechanism: lock, mint, and then burn, unlock. Okay, and you can say this as a transfer, and then there's a redeem process. And the second one is cross-chain asset swap. You actually do not lock the asset on the source chain. You actually exchange. You have two liquidity pools on both sides. So when you want to transfer, you just exchange with the liquidity pool. So you just transfer the ownership, and then you let another liquidity pool to issue that token to the target address. So this, you don't have mint or burn. You just exchange with the liquidity pool. And this way, it is better for managing third-party issues tokens. Because with lock, mint, and then burn, unlock, the smart contract actually has the right to mint the asset. But with the asset swap, the smart contract do not mint it or burn it. It just exchange with the liquidity pool. So it is the second piece is more versatile when you have the third party providing that liquidity pool. And then another mechanism is called export cross-chain function calls, and this is what we are kind of proposing here. We do not do mint and burn or swap for you. You build it yourself. We just provide the messaging and function call layer, but you need to build it yourself. Okay, so this is what we are focusing today. Yeah, so here's what I'm suggesting here. So project statement, if you want to build a project, submit a hackathon project for VeChain today, or I think September 22nd. This is what I'm suggesting. You create a cross-chain application using Wanchain XPort messaging passing SDK. We have that already. We have documentation. We have developer handbook for you. And then the application should facilitate interactions between VeChain and other EVM compatible blockchains. Okay, also together, combined together. And this you need to build is a great project. You need to build a smart contract for the EVM chain, for your VeChain, and then another smart contract for the Ethereum chain or any chain you choose that which is EVM. And then you need to follow the export specification, and then you can let these two smart contracts talk. and then you can implement like a ERC20 quad-chain transfer application, or you can have NFT 721 NFT asset transfer. You can also build decentralized applications. Okay, and here are some resources. I'm going to come this later on, but I have a we have a handbook document for you. We also have some examples for you. Then I'm going to talk about it later in details. Okay, so what are the things that normally needed? Okay, these are the general prerequisites, but for VeChain, there will be more requirement because you need to have the vWorld. You also need to have a XRP proxy, and you also need to have some VeChain, of course, the VeChain TESTNET Explorer as well if you are deploying to TESTNET. But here, the general requirement for building a quad-chain application, you need to use, you can use, okay, Remix compiler and deployment tool. Of course, you can also use any compiler you want to use, or use a hard hat to deploy the smart contract, no problem. But normally, if you are new and you want to have visual things, and Remix compiler has been a wonderful tool. It's online. You don't need to install anything, and then you can visually try a lot of things with Remix. That's what we recommend actually. And vWorld is good. VeChain is good. They also have vWorld. They're actually compatible with Remix, but there are some catches there because the vWorld extension does not directly working with Remix, so there'll be something that you need to work out the more details. And actually, VeChain has good documentation for that as well. And then you need to apply for testnet tokens. Okay, so you need to go to VeChain, apply for VeChain VET token, and you also need to go to Sepolia, which is a testnet of Ethereum, to apply for some of the testnet token. And then you need to understand export cross-chain messaging protocol, and this we have a handbook for you, and I'm going to walk through it as well. And then you need to extend your smart contract on top of SDK, because we provide a framework for you. So you just need to stand on the shoulder of the giant to extend your smart contract on top of these SDKs. So your lines of code could be even just 5 lines of code, or even 20 lines of code, because we built everything else for you already. We even have the relayer for you for the core chain already. So you should extend your smart contract on top of that. And then you build an UI and use Web3 to talk to smart contract. Basically, you provide a kind of Web2-like GUI running on browser, talking to the blockchain smart contract on the Web3 layer. So that's what you do with a core chain application development using Wanchain XPort. Yeah, then I'm going to go to some details. Okay, so first, suppose the example. Okay, suppose you want to do NFT core chain application. Right? And the first question is, why do you want to do NFT core chain? Right? If you just think about, you have a picture, a wonderful picture or story, you want to create an NFT for it. Or normally, you need to deploy it to VeChain, deploy it to Ethereum blockchain, deploy the Polygon, right? Or you have to use a centralized kind of a NFT market for you. But using decentralized messaging, you can build NFT application or token in one blockchain, and that NFT token to be used by all the other blockchains, which means that all the other blockchain that has asset can buy your NFT that is deployed to VeChain. So when you deploy NFT to VeChain, that's it. You don't need to deploy that NFT to VeChain or to other chains. You just need to deploy to one single chain of VeChain, and then that is holders to buy your NFT from Ethereum blockchain. Right? So that would be great from development's point of view. Okay, so NFT is because you have different background. I just want to. I suppose most of you know about this already, but I just want to say it in case some people don't understand. So NFT is a standard for a non-fungible token, which means that every NFT token has a unique identifier, and then it's minted with a unique identifier with a unique owner. and then NFT token can be transferred. But this NFT is based on ERC 721 specification in the Ethereum, and I think VeChain supports it as well. It's one of the most popular non-fungible token standard. But that NFT does not go across different blockchains. So you want to build an NFT that can go to different blockchains. And the way to write NFT code is very, very easy. Okay, it just need to, I don't know how many, there's about 10 lines of code here. Okay, and because I have been in different blockchain, teaching to different blockchain hackathon, the different hackathon, have been talking to different hackers, and some of them know blockchain very well, experts, but some of them are just new to blockchain. Okay, they just come to hackathon to learn about blockchain. So I just want to say that, okay, to do this project, you need to know about Solidity programming language. Okay, that is a language for smart contract development, and that is required for this hackathon for Wanchain. And it's not difficult to learn. You can just go there, spend 3 hours, and if you are familiar with Java programming or scripting, you should be able to learn in 3 hours. So this is one example of NFT sample code. Let me go through it quickly, so that you can actually write this learn this in 3 hours if you are not familiar with Solidity at all. So basically, you have a first line is Pragma Solidity version number. You just say this, I'm a Solidity programming language here. And then you import, and this is the giant. Okay, everything has been implemented for you already. Okay, you just need to extend your smart contract on top of the ERC 721 Solidity program that is based on standard. So you are extending your 721 NFT token on top of a standard 721 token that has been implemented by other people for you. So that makes your job very, very easy. And then you just need to say that I'm doing a Texas Technology College diploma NFT token, which means that this smart contract is going to issue a diploma for a student who graduated. Okay, so and easy. I just want to name my smart contract of TTC diploma, and then is ERC 721. Is means that I'm extending, if we are Java programmer, that just extends from ERC 721, which has been implemented by other people, which I import from here. So once you extend here, all the ERC 721 functions that are specified in the ERC 721 specification are imported to your smart contract already. So you don't need to write anything of it. So you have about 10 or 15 functions imported here directly. You don't need to write anything to it. And then you just need to say that I have a token ID for each diploma, and then I have an address admin to manage the issuing of the token. And then I will have a contractor, means that when I deploy this smart contract, I'm going to name this smart contract diploma smart contract as Texas Technology College diploma. And then I have a symbol called TTC. So during the deployment time, I can specify this smart contract to be a diploma NFT smart contract with this name and with this symbol. And then I just say admin is message.sender. And message.sender is a keyword. It's the person, the author that's deployed the smart contract. So whoever deployed the smart contract is the administrator of this smart contract. Okay, so that's in the constructor. And then in the function, you just need to say issue diploma. So with this issue diploma, we'll take the address of a student and then take the URL token URI to the smart contract, which means that for each student, you can assign a web link to that student address, which represent that smart contract. So, and here you need to have several checks. Require means that you need to make this condition to be true. So you require msg.center equal to admin, which means that only administrator can issue the deployment, can call this function. And then every time when this is called, the token ID increases, because we know that the NFT need to be unique, and each time the token ID will increase by 1. And then from there, you just mint a token for the student with the diploma ID, and then you set the token URI, which link that address with the URI or URL that represent the diploma of the student, and then you return that diploma ID. So this, with just a few lines of code, you implement an NFT smart contract, and every time you can call issue diploma function to issue a diploma to a particular student with a particular format of a diploma. So this is NFT sample code for one single chain. In fact, you can copy this code and use Remix to compile it and deploy to VeChain, and you can claim that you develop a college diploma smart contract for the world, because VeChain is globally accessible. So basically you deploy it for the world, and then you need to build a UI that looks good. You don't need to have a server, you just need to have a UI, and you don't need to talk to any authority. For that, you just need to deploy the UI, and then from there you say, I issue this smart contract. And the challenge here, of course, is that, will people trust your diploma? That's the real issue. Okay, but here we just talk about technology, and the authorization, other things, that's another separate topic. So simple example, a few lines of code, you should be able to write NFT token deploy to VeChain, and then that smart contract on VeChain to be accessible to all the audience in the world. Okay, so it's not that complex. Yeah, and then the NFT develop. Okay, there are some community. These have been built by other people already, and actually the underlying technology is fairly easy. So using that technology, you can build a similar application marketplace as well. Yeah, and then I just talk about it. NFT you deploy to VeChain, great. Okay, it's accessible to the world, but there's still some limitation. Okay, first, it's confined to blockchains that when it's created. I have Ether, I have Ethereum blockchain. I want to buy your NFT, or I want to get your NFT. I cannot do that because there's no way for Ethereum blockchain to talk to VeChain, right? So that's one drawback. But we solved that problem by partnering with through VeChain and Wanchain. So that is good. And then for physical asset, which chain should be used to create the NFT, right? And then there's a lack of cross-chain application for NFT, so you need to build that. Okay, so yeah, and then this explains why you need to have NFT cross-chain. First, NFT cross-chain NFT asset can be cross-chain transferred to other blockchain for trading. If you want other blockchain owner or asset owner to buy your NFT, you can cross-chain and let people buy it. And then you also can save some transaction fees and improve scalability, because you can deploy your NFT to the best blockchain with low transaction fees, things like that. And VeChain is a good candidate of that. It's fast and it has low transaction fee, so you can do that, have your choice. You don't need to deploy to Ethereum all the time. You can just put it in VeChain and let the cross-chain handle all those trading exchanges. Yeah, and then, yeah, min ones use anywhere. So that is the power of cross-chain. So I think Wanchain has implemented some of the NFT cross-chain use case already. So basically, you have create an NFT in the source blockchain, and you can transfer the NFT to other blockchains. So I just want to show you. You actually, if you go to bridge.wanchain.org, you should be able to see some of the NFT cross-chain transactions. But I'm not going to go through these details because these are at the application user level. You are developer level, so I want you to go through the export, which I'm going to touch it gradually here. Yeah, this is a Wanchain example for NFT cross-chain use case. Yeah, so I show you this here because when you build it, you may want to refer to similar format, right? But for example, you have the asset name, and then you have the chain, VeChain to like this is or this is not VeChain. It should be VeChain to Ethereum, and then you have the form this address to the recipient address, which is on the other chain, and then you have the identity, and then the fee, etc. And then you can say quad chain, and this will make the entity on VeChain to other blockchains. Yeah, so and then this is the NFT, the quad chain flow. If you want to implement this one, okay. So initiate NFT token transfer, which means they want to transfer token from source chain to target chain. From the NFT quad chain bridge, user connect to his or her wallet, such as MetaMask. But if the source chain is Polygon or Ethereum blockchain, so then you use MetaMask. If it's in VeChain, you use a vWorld. And then you choose NFT to transfer and specify the source chain and target chain, and specify the target address. You need to give it the target address on the other chain to send to. And then you send the transfer request, and then NFT asset get locked by the smart contract on the source chain. And then you can then the mirrored NFT get transmitted on the target chain. So at that point, the NFT asset quad chain event is emitted, and then the bridge node detects the lock event. When you say I want to transfer, an event is emitted, and then the bridge node that we operate, Wanchain operate, will detect that lock event, and then NFT asset is minted on the target chain. So this is how NFT quad chain workflow works. Yeah, and then redeem is the other process. Okay, when you want to redeem that one, you just burn the NFT on the target chain, and then you detect that burn, and then you unlock the NFT on the source chain. Okay, so this is how the redeem works. Yeah, and I think this is, if you do this NFT quad chain transfer, I think the application should be a functional end-to-end prototype of a decentralized application that does quad chain transaction on the VeChain blockchain, and there, I mentioned that already. But this is for NFT, which means that you need to lock NFT on the source chain, mint it on the target chain. Yeah, now I'm going to go into, I hope I did not confuse it right now. Are you still okay? Everybody okay? There'll be more.
Yes, great. Thank you. Thanks.
Okay.
I actually just have a quick question to clarify. So you were talking about the messaging aspect of things, right? Instead of just a bridge. And here, instead of saying like NFT transfers, we would track events from one smart contract on one chain to another smart contract on a different chain, right? And emitting an event on one chain on, say, Ethereum would then mirror or emit a different event on VeChain, for example.
Yeah. You can you can emit those events, then they'll be detected on the target chain. Yes. And then we do because when the event is emitted, right, it was detected by us. It's detected by Wanchain. So you don't need to do the relayer by yourself. We do that relaying for you. Yeah, so and I'm going to
great. Sorry, I didn't want to interrupt you while you were on a roll. So I just wanted to clarify that that was the case, right? And so that can kind of frame how people might develop different solutions for the hackathon. So that's fantastic. Weijia, I'm going to let you carry on because I know you've got a lot to cover.
Yeah, we still I haven't gone to Remix yet. We still want to go to Remix interfaces and then vWorld as well. So let me go through this high level first. So example of export quad chain messaging implementation. Okay, so here we are talking about asset transfer, value transfer, which is a little bit different from NFT. We explain NFT over there, but here we have another case, which is a value transfer. And for this, okay, we need to have VWorld, which is a wonderful wallet by VeChain. And VWorld actually has different format. It has a browser extension, and then the mobile app. Here, I want to mention this because it's a little bit different from MetaMask. And I want people may. I spend time on that, and I figure out if I don't say this, some of you may need to spend more time to figure out some of the things. I actually talk to my developers and say, how come I did not know this? And I say, well, you need to look at this document, look at that document, and I figure it out. First, I mentioned that Remix is the best smart contract tooling. You just go to an app website, type in remix.ethereum.org. You have the whole IDE integrated development environment for you already. You can compile, you can test, you can deploy. Wonderful. And VeChain, if you look at the document, say, oh, VWorld support compatible with Remix. Okay. But there's a catch there, because when this VWorld is compatible, it means you need to use a wallet connecting to a VWorld app. That's one route. You need to have a kind of mobile app to install VWorld on your mobile app. Then you use Wallet Connect through Remix to your wallet. Okay, and some of you may not want to install the wallet right now in the hackathon process. And then they have another way, which is the RPC proxy, which means that you have to install VeChain RPC proxy on your local system, and that proxy actually talk to Remix as a browser, and that proxy actually kind of send transactions to the VeChain testnet. And that one, it doesn't actually touch the VWorld extension, but you still need to VWorld extend kind of wallet to manage some of the asset over there. Okay, so these are two things. So the important thing here is Remix does not work directly with VWorld extension right now without workaround. Okay, so that's important. That's what I want to mention here when you're doing the development. And on the EVM side, the Remix is working 100% compatible with MetaMask. So there's no problem with the EVM side, but you need to have some workaround with the VWorld. Okay, so that's environment. Then I'm opening up this. Okay, I'm going to give you the real example. It's just some screenshot of it where I need to work through the workflow here. And this is one picture of Remix. Just type in Remix, remix.ethereum.org. You're going to have this whole complex screen here. And then on the left side, these are the controls: file listing, compile, deployment, testing, right? And then this middle panel are the kind of more details on the file listing and other things. And then you have the file here, and you can just you want to compile a file, you just say new file, and then write the code over here, and then you say compile, and then you compile it, and then you deploy, and then you deploy to VeChain and other chains like that. Okay, so this is a Remix development environment, and this is one example application that we built for you already using export on VeChain. Okay, we build an example application for you as an example to connect VeChain's token with Sapolia token with the testnet for Ethereum, and then using Wanchain XPort technology. So I'm going to show this how this works. So this is the UI that we built. You have a quotient bridge, and then we have a token smart contract on the Sapolia chain, and then we have the token smart contract on the VeChain, and then you have the ERC20 token for the Sapolia chain with Ethereum chain. So these two are the applications. So the top one is the application on the Ethereum testnet. The second one is the smart contract on the VeChain. And this one is the token for the salt chain, which is the Ethereum testnet. And then from here you can say this is the balance here, and then you can transfer token from the salt chain to the target chain. Yeah, so from here you can say that this is a real example. I actually deploy this and then do the transaction. So well, this is refresh balance. Amount to bridge. This means that how many token you want to lock on the salt chain and transfer to the target chain. Here I say 40, and then this the fees. Okay, you want to pay for that, and this could be adjusted. And you just say, I want to bridge 40 token. And the moment you click here, it's going to lock the asset on the salt chain. And then you mint the asset, same amount of asset on the target chain. And the beauty of this is that I'm going to show you how you can write it in about 30 or 25 lines of code. Okay, so be patient. We're getting there. Okay. Yeah, and once you click bridge tokens, okay, we have another page showing that the process of the transfer. Here, then immediately amount of bridge becomes 0 because you start bridging already. It's no longer 40. You start with 40. But once you lock it refers to 0. And then it shows the cross-chain status here. And we actually track the status with our UI. And then after 10 or 10 minutes, it becomes success. And once it's success, you see that there are 40 kind of target token minted on the target chain, and then on the salt chain, you have 40 token less because it have been kind of locked already. So this is how you achieve cross-chain transfer. And with the partnership of VeChain and Wanchain, we build that bridge, we build that UI, and then this is a user application. So you just need to use that for bridging asset. But in today's hackathon, in this time's hackathon, you are going to use export, database export, and build the application for yourself. And this is not just about token application. You can build any cross-chain token cross-chain application you want, okay, by using the library that we have. So thank you for this one, and then we're going to go to more. Yeah, okay. Luis, do we have questions right now? Because I'm going to go to more details. We're going to go to the handbook, and we also go to the remix.
Yeah, no, we don't have any questions now. It's just the clarifying one about messaging before.
Yeah.
I mean, I'm excited to get stuck straight into the next part, to be honest with you, Weijia. So just crack on, mate.
Okay.
Actually, you know what? Just quickly before we do, for everyone listening, I've put a link to the export documentation in the description of the live stream. So you can go and check that out. It's just down below in the description as well. So if you're looking to follow along while we move into this new section of the workshop, then you can find the link just there.
Yeah, okay, let me see how. Yeah, do you see that? Can you see that? I changed the screen. Okay, so.
Yeah, I can see that fine. Thank you.
Yeah, export developer handbook. Okay, I explained a lot of things to you already, which means how you mint token on the source chain, and then how you transport that token to the target chain, or lock the token on the source chain, transfer the token to the target chain, then mint it on the target chain. Right? And if you do this by yourself, you'll be months of effort. Okay, but today is that easy. We have an export developer handbook. And what do? Okay, first that we deploy some libraries on the source chain. And these libraries are called, we have Wanchain bridging library, bridging gateway. And then we have interface of Wanchain application. Wanchain messaging application gateway, and then we have both on the source chain and on the target chain. So because smart contracts are kind of object oriented, once you have those libraries or interfaces, you can extend on top of it, right? So it becomes very, very easy for you to extend it and then build application on top of the framework that we have. And then we also run the relayer, kind of off chain, to carry the message from source chain to the target chain. So if you look at this way, because you are going to, if you are building this application, you're going to see this a lot. So I'm going to just go through it. So first about this handbook is that as a guide to help you understand the export, the core chain messaging data transfer protocol to build core chain application. So the goal is very simple. Use our library, use our framework to build the core chain applications. Okay, and I just give you two examples: NFT asset transfer core chain or ERC20 asset transfer core chain. And you can also build core chain applications, core chain lending application. There are a lot of things that you can build. Core chain identity, a lot of things can be built. And then core chain data transfer, is spent a little bit on that. Yeah, these I explained already, that we have an option layer that we build ourselves, and then we have a smart contract that we call the core chain gateway that we deploy already. So getting started, you need to have a smart contract development environment. Okay, and I touched this one already for you. I said Remix is the #1 development tool. Okay, and of course some of you may say, hey, I want to use a Visual Studio. No problem, you can use that as well. And then that's for coding, but you still need to have the deployment tool. And then you say, hey, what's the best way to deploy a smart contract to VeChain? Okay, and then you say, oh, Hardhat is the best way, or you can use Remix combined with reward Boss wallet. So these are the choices you can make there. And then because you need to have two development environments, okay, one for VeChain, one for Ethereum. And so that's why I think Remix is good because it works on both chains. But when you are working with VeChain, there are some things you need to pay extra attention, some workaround you need to go through, okay. But there will be VeChain people to help you with that. I'm talking about the RPC connector. Remix RPC proxy connector, you need to have that, or you have the mobile app installed on your wallet. Okay. So, and then the bit detail here describing how you can create a project over there. So I actually have a book over here. So actually, you want, you can read a book. But this is just normal knowledge about how you compile smart contract. Yeah, and then you need to have write your smart contract called my contract is WMB app. Okay, this we provide that base for you already. So you need to just extend your smart contract from here. Wanchain Wanchain messaging bridge application, we have that already. So you just port all those to you, and these are kind of can be imported from the one tab here. So this is provided already. So you just need to extend it directly. So this here, then you write your code below that one. So this is your code, okay. So this is writing the smart contract on the source chain, and then you describe that you need to implement the function of Wanchain web message receive. Okay, this one describing when you receive the event, what you are going to do with that. So you just write your function here. So you just extend that function and then write your own operation that you want to do. Right. So this means that when you receive a message, you want to invoke a quotient, invoke exchange, or you just want to mint the token, or you want to do mint the NFT, or mint NFT, or mint ERC20 token, or do other things. It's up to you to define. Yeah, and then you have a constructor. You need to define that when you deploy your smart contract, you need to have the admin here, and then you define the gateway. You need to specify the gateway address for your smart contract. I'm going to have example for you later on. And then you may need to describing the chain ID, because you have two chains communicating with each other. You need to specify the chain ID and then the target chain address as well. Yeah, and then these are the things that also you need to write the send message here and following this format. So which means that when you mean that when you lock that token, you need to send the message out, and this should follow this format. So these are the things that, and then you also need to implement the estimate fee. This is how much fee you need to pay, estimate, so that you know how much you need to deduct for this quad chain. Yeah, and then you also can implement this estimate fee here. I describe some of the fee requirement here, and a dispatch message. This dispatch message is from our library. So you just need to say several things. First, you extend from our library. You specify the dispatch event. You also send the message out, and then you do the receive message. When the message is received, what you're going to do, you describe those functions already. So these are a few things that you can do, and then you write your own code here. And because it's a little bit abstract, I'm going to give you examples for that. Yeah. So if you look at it, now you may say, oh, this is fairly simple. And the reason it's simple is because the library, the SDK, is doing all these things behind the scene. So you just need to say a few things, saying that I'm sending this to that blockchain, and once I get to that blockchain, I'm going to either mint or burn or do something. Okay, I'm going to give examples for that. And then the supported blockchains, and there are several things important. For mainnet, we support Polygon, BSC, and Wanchain. A lot of these things chains have been supported already. And then for the testnet, this is important for you. The testnets, we are supporting different chains, and then we also list the VeChain here. Okay, and then VeChain, it just added because it's just added for this hackathon. So you need to know two things. One is the VeChain's gateway address. This is the gateway smart contract that we deploy for you. So you need to, when you write your smart contract, deploy a smart contract, you need to mention the gateway so that your smart contract can talk to that gateway, because we only communicate to the gateway. Then you need to talk to a gateway. So you need to know the gateway smart contract address. And this one is the chain ID. So you need to have this here as well. And when you are doing the quad chain between VeChain and another chain, you need to get the other chain's gateway address and the chain ID as well. For example, if you are talking to Polygon chain, you need to get Polygon's gateway and then chain ID. So these are the two parameters you need. Was the WMB gateway address and then the chain ID. So you need to have these two. Yeah, I think that's the handbook that you have. You have all the parameters you want to have. And this is also, there's a GitHub here, GitHub address here. You can always go to GitHub to find out the latest information. Actually, I just asked him to update the VeChain information just the day before yesterday, the latest one. So you probably don't need to check this one for the latest version. But in case you want to look at more, you can go there. So this is the handbook. It has a lot of information over there, particularly the gateway address and the chain ID. You need to have that. Okay, so another thing, the handbook, there's a great resource you have. And I'm going to give you another thing. Remix. Okay. This is the Remix kind of IDE, integrated development environment. And I'm going to show you some of the examples that we have been kind of talking about. So on the top left panel, there's a file panel here. And actually, I kind of create some of the files here already. So there are some code for ERC20 token transfer, which means I want to lock a token on source chain and then mint the token on the target chain, cross chain, okay? And I'm using Remix to compile and deploy. Okay, so if you look at it here, I have my ERC20 token here, right? And they're very simple. This is just. Can you see? Is the font good now? Reese, can you see it? Okay, cool. So the code is very easy. It's just simple. It's just even simpler than NFT token. Just 5 lines of code. Of course, you import it from OpenZeppelin. This is the project that implement all the token specification for Ethereum. And this is the ERC20. So you import from there. And then you just have a contract called mock ERC20 token that you create. It's your token. And then you can say this is ERC20, which means that you're extending from ERC20 token. And you have a constructor saying ERC20, the name, you input the name of the token and then the symbol of the token. Okay, you can, and then you just say, you can just test my token of VeChain. VeChain, you can even change it to VeChain. And then you have a function called mint, okay? And then you have mint2, mint amount, and then you call this underscore mint, which means that when you have a mint function, you're going to mint this amount of token to this address. That's it, and that's your smart contract. Okay, and here you can just change it. One thing here, you just compile this ERC20 token here, and then this will be your smart contract. This compiled smart contract. And the second thing is that, okay, how can I deploy this smart contract to VeChain or to Ethereum blockchain, right? And that's another thing. You need to use vWorld or use or Hackathon to deploy that. But today, I just for this demonstration purpose, I just want to deploy to the local EVM here. So I'm not going to go out to the blockchain to let this smart contract that's just for demo, not to deploy to the permanent blockchain. So let me show you how you deploy it, okay, and show you how that works. So I just choose a Remix VM, which is a local VM here, and I'm going to deploy this smart contract here, and I just do deploy transact, and you can see that, yeah, it's I call it mock. Remember, I call that the token smart contract mock ERC20 smart contract, and I deploy here. And if I click this one, it could be useful for you who are not familiar with Remix, and you can see that I can click at that. Remember that I call it test VeChain, so that the name of the token is test VeChain already. So 5 lines of code, you deploy a smart contract for ERC20 token already. And then the symbol, remember what's the symbol there? The symbol is test, right? Yeah, and the symbol is test. Okay, so you have that already. Okay, so very, very easy. Okay. So after this, you can immediately, you don't even need to do question, you just immediately write 5 lines of code and then say this is my token, majority token, majority #1 token, and then assign 20 million token to yourself, and then you deploy to VeChain and saying that majority has a token of total amount of 20 million already. Actually, it's just 5 lines of code. And this is how powerful smart contract is. And this is how powerful EVM blockchain is, including VeChain. So 5 lines of code, write it, deploy it. It lives in the blockchain forever, and everybody in the world can access it. So this is one simple example of ERC20 blockchain writing. Okay, you have that, but this is not enough. Okay, this is just one token smart contract for one single blockchain. We want to go beyond that. Okay, so going back to the file panel, we have this token already, and we want to lock this token. After we lock this token, we want to mint the same amount of token on the target chain. Okay, how do we do that? here. So you need to create another smart contract. Okay, so that's called ERC token home smart contract. Okay, so and here, oh, this is a bit more complex now. You deploy, you kind of copy some of them. Let me see. Okay. Oh, yeah. Well, Remix even have AI. I just didn't know that. Even have AI integrated, which means your coding even more easier. So if you have a problem, AI will find that solution for you. So you want to use this, you write the token, you want to write a smart contract that kind of can lock this token, and then that the other smart contract on the target chain to mint another token on the target chain. So what you need to do is very easy. So you can have a ERC20 token home, which is extending from WMB app here, and you need to have that, and then we have that already. And then you need to use some of these for ERC20 token kind of functions. And then you have a address, token address, and then you have the cross to and cross back some event. You need to specify the cross to event and cross back event. Okay, and I think Luis asked that question before. How do you detect event? We detect those events for you. And then the constructor here. Okay, when you have constructor, you need to have a web WMB gateway address, and this is why in the handbook I ask you to know about the gateway address, or that right there, and then you need to have the token address. So when you write this smart contract, you need to input two things. One is the gateway address, which is the gateway address that we implemented for you, which we documented in the handbook, and then you have the token address. And this token address is the smart contract you just deployed. So this is the constructor. Everybody know about constructor, right? Constructor is a function, it's a function that is called one time only during the deployment. Once you deploy that smart contract, you cannot call constructor anymore. So anything you want to initialize, but not to change it anymore, you put it in the constructor. And anything you want to call multiple times, you make it into a regular function. So the constructor need to take in two parameters. One is the gateway, one is the ERC20 token that you have created already. Yeah. And then you have a quad2 function, and then this describing that when you have a quad-chain processing, you need to lock the event, transfer the when we say lock, you may not do things like that. You may just transfer your token to the smart contract. That's what we call lock. So you actually implement the lock by transferring the token you own to the smart contract, right? And then so it does things like that. So it basically is a safe transfer of token from user's address to the smart contract address. And then of course you do the balance, some of the balancing, the calculation over that. Okay, so this is just normal for any transfer, any lock, you can have that. Of course, there are some check here required. Matches value equal larger than fee, which means that you need to make sure that the fee you specify, you send is more than what's required by this bridge. And then you need to have the bridge here sending dispatch message to the remote side. And so this is what we implemented for you. So you just need to call this one, and you need to emit the cross-to event. And then you need to also implement this receive function. This receive function is that when the other side send a message to you, you are going to do this operation. So basically, this is the unlock. Okay, when you receive this one, it's going to be unlocked. Yeah, and I think that's it. That's one from the source. Okay, so it's very simple. Okay. So you have a token created, You just input that gateway address, put the token in, and then you can specify cross to or cross back. Basically, receive is taken back. Okay. So I want you, when you start this project, you can read it clearly, and then you should be able to figure it out. If any question, that I don't know. So this is the question for token. So I'm going to compile this one as well. So here, let me see. Yeah, this compile. I'm going to compile this one. Oh, it compiled, successfully compiled. Okay, and then it's compiled, and then I'm going to deploy it. So I still deploy to the same local EVM here. So I'm going to compile. When you look at deploy, well, compile is also called, no, deploy here. It compiled already. So it's there. I'm going to deploy this ERC20 token home. This could go to VeChain or go to Ethereum chain. And this is called deploy here. And you can see that there are two parameters you need to input. One is the gateway address, and one is the token address. Remember that when in the constructor, we have constructor function with taking a gateway address and also taking a gateway address and also taking a token address. And where is this token address? This token address is the smart contract that we deployed, that you just wrote, called test VeChain token, right? So, and that is here. So you can just copy it here. You put it here. This is your token address. And where's your gateway address? Okay, if you are my classroom, I'm going to take this as quiz. Okay, but nobody answer here. But the handbook, remember the handbook? I tell you that there's a VeChain. In the VeChain, there's a gateway address. So let's go there and copy it from there. I think this browser is kind of a problem with, let me see. Oh, no, wrong.
I grabbed the VeChain testnet one from XPort. I've just popped it in the chat for you, Widger. I hope that's the right one. Here's the testnet one we're after.
Yeah, I think that's good because I have problem switching the tab here. That's my problem. Because the top bar is controlled by the screen. Then how can I? It doesn't let me move that thing. Can I do this through the tab? No, I cannot. Oh, yeah. Okay. Yeah, coming back here. Yeah. Okay, you grab it, you send it through the chat. Okay, Thank you, Riz. You're so helpful. So Riz helped me to grab that gateway smart contract address from the handbook, developer handbook of export. So I have it here. So I just put it here. And then I do the deployment. And then you can see that I think it deploys successfully as well. I want to be more careful now because with this thing. Yeah, and this home is available here. Yeah, so I deploy it here. And you can see that there's a cost to that's here already. And this is the one that you can send to the user with this amount. You can transact like that. Okay. And then you can also, the remote chain ID, or this not there's no remote chain ID right now. And you can estimate fee here, receive here, all these functions can be called. And let me see the token. Yeah, this is the token. The token here is this token. This is the token. This is the token that you created, and then this is the gateway that Reese just sent that to me. Okay, and this is the smart contract on the source chain. Okay, so this source chain will talk to the gateway. It also talk to the token that you created. Basically, it's going to lock your token, send it to the gateway. The gateway will then back send to the target chain, and then mint on the target chain, or vice versa. So it's very simple. Just write a smart contract. You handle cost chain 2, cost 2, and cost back both ways. And then so this on the source chain. Then on the target chain, which I call it this one, ERC20 token remote. And then here, very similar thing. Constructor, this is the one that run only one time. You can see that it takes more parameters now because you need to take the gateway address, remote smart contract, because you need to talk, because this is remote execution, right? You are on the target side. You need to know which one you are allowed to talk. You don't talk to every smart contract on the source chain. So you need to specify the gateway address, which is the Wanchain provided gateway address. If you are on Ethereum blockchain, you need like a sub-layer, you need to know that gateway address and then input it when during the deployment. And then remote smart contract. This is a smart contract you just deployed on the source chain, the one just deployed, that home, ERC20 home. And then you have remote chain ID. Remember, I mentioned that there are two things important. One's gateway, one the chain ID. You need to grab that chain ID as well. And the reason for specifying that is you want to authorize which blockchain can talk to you, which smart contract can talk to you, right? And which gateway can talk to you. And this is very normal. And that's why you need to have all these kind of information. And then you can, and from there, of course, you can also implement other things as well. And then you can say cost back. This is how you kind of want to burn things, and then receive here. So once you receive a token kind of event, what are you going to do? So here you can just say that once I receive this cost chain mint event, I'm going to mint this amount of token for this user. And that kind of closes that loop. On the source chain, you say cost 2, and then we dispatch that message saying that we want to cost to this particular blockchain, and then here receive. And then when you receive that, you want to mint the same amount of token for that particular user that you specify. Okay, so that closes the whole loop. Source chain, target chain, 2 smart contract. We're using Wanchain's export gateway. Right? And then you can compile it. And you can see about 20 lines of code. So it's very easy. And that's all you need to do. These smart contracts are the things that you need to do. Okay. So you add it up about 14 lines of code. Very easy. And that's because the kind of foundation have been built by Wanchain and VeChain. Right. Okay, so we compile it, and then when we deploy it, okay, if you deploy it, okay, this is the other one. Yeah, you want to deploy it, or you need to specify the following information, because you are a target chain, right? You need to have more checks. Okay, you need to specify your gateway is provided by Wanchain. You need to specify the remote smart contract, which is the one you just deployed. You need to specify the remote chain ID, which you can find in the handbook, and then you need to specify the name and the symbol this is the name and the symbol of the token on your target chain. Okay, this is not the same as the one on the source chain. You can name it whatever way you want. For example, you can say mirror token here and or some other token. Actually, this dynamic, we just leave it as a constructor parameter, so you can specify that. So you need to specify all these parameters, which you know already, and then deploy that smart contract. So this closes the loop for smart contract. Once you deploy all these smart contracts, they are on blockchain, in VeChain, on VeChain, or another chain that you want to implement, they'll be there forever. And the next important thing for you to do is to build a GUI for user to interact with those smart contracts. And this is almost Web 2, so it's straightforward. But no, it's not straightforward. Actually, this is the most complex one because this is the piece that touches the users. You need to make it use. You need to consider usability, security, scalability, everything, every check, right? And this is the tougher part of the. Okay, when I say you can deploy that, you can write the decentralized application for 50 lines of code, 40 lines of code. I do not take that GUI into consideration. In fact, that's the most difficult part. Okay, smart contract easy, GUI very, very complex because that touches, that's a human and smart contract interface, most difficult one. Okay, so far I wrap all the smart contract for you already, and I'm going to leave the difficult part for you, the writing the GUI, and then writing the Web3 interaction. Those are easier. The Web3 is easier, interaction easier, but the GUI is the most difficult part. But I'm going to close this one because the smart contract development here is wrapped. And I'm going to go to the back to the presentation. Okay. Yeah. So this is how we implement GUI. Okay. So because we deploy all these smart contracts, we put all the smart contract here, and then we have this GUI. Okay, we actually have bridge here, and then the V word. Okay, look at our GUI. Yeah, we look at our GUI here. Let me move it a little bit. Oh, what's going on? Okay, yeah. So we have, let me move it. Yeah, if you look at the GUI here, we have a top panel here, the deploy, bridge, advanced, the vWorld. You can show two wallets here. The vWorld wallet, this is the wallet for VeChain, and then we have MetaMask wallet. So in the GUI, you need to have these two browser extensions installed all together in one blockchain. If we have one single wallet that can handle everything, that'd be great. Okay, you can say Omni wallet, okay, or maybe it is universal wallet, that'd be good. But no, we still don't have that yet. You need to install vWorld wallet and install MetaMask wallet separately. And then in this here, you can have all the kind of quotient bridges information here. You can hide this. It's just for developer use consideration. And then you need to specify the balance of the wallet. And then you need to say supplier to VeChain, or you can click this one. We have this one. It means that you reverse. Okay. With this, if you click this one, it becomes VeChain to supplier, and if you click it, it goes back. And then you just need to specify the amount to transfer and then the fee you want to pay, and then you just click bridge here. Actually, there's one more catch here. You need to put approval as well, because bridging actually need two parts. You need to authorize the token to be spent. So there's approve, and then there's a bridge. So you need to have another button here. Yeah. And then once you click on that, you will trigger the quotient events, and then you're going to in your application, you can implement the quotient status here. You can check for the event, and then it's minted, you say success. If not minted, you can just say processing or error over there. Okay, so this is the most difficult part of building a GUI for the quotient application. So I'll leave that for you or to you. Yeah, I think Luis, I think we have a lot of content covered already. You can always look at the resources. These are the major resources. We have one demo example for you with all the source code. And then you also can look at our development handbook to figure things out. Yeah. And I want to thank you for taking this time for this workshop. Yeah, Reese, back to you. I think we can leave some time for questions or if they are.
Yeah, that was great. Thank you. So I do have a question. What we've looked at in this example is transferring tokens or assets across chain. But one thing that I think as people have asked is about making or having a reaction to an event. So for example, if like a message is sent to through a contract, like an event emission, rather than a token transfer necessarily. Is there a way that we can do that with a Wanchain?
Yeah, sure. That's easy. Okay, remember I have there's a dispatch. There's a cross to dispatch and receive, like WMP receive, and then there's a dispatch as well. If you just want to handle event, and in the application we mentioned that in the receive you say I mint this one because I take actions, right? And if you just want to you don't want to do anything, you just want to know something happened, you just remove that emit. Don't cross out that emit word and mint word. Just say that emit event, say you can emit another event on the target chain saying that, hey, I received that. Emit,
Yeah.
you can emit the event call or log something, output a message saying that, yeah, Houston, I received, and that's it. So don't do
Because I
anything.
think, no, that's great because I think that actually clears up a lot of things. Because in the context of kind of the different tracks for the hackathon, it makes sense to understand those kinds of options because something that like we have with VBeta might like if I'm thinking of what kind of potential projects people might build for the hackathon, it might be something that reacts or rewards users based on certain events happening on a different chain. And I think that's like a really interesting kind of application that someone might build for the hackathon. So that was why people had asked it, and that's kind of I think the context around why.
Yeah, in fact, you're asking the right question. In fact, we have another example called ping pong event, ping pong application core chain. And then the source chain will be a ping, and then the target chain will be pong. So it doesn't do anything. So the source chain will say, when you say core chain message, the source chain will say ping. And then the message will be conveyed to target chain, and the target chain will do nothing except saying pong, which means I received the message, and that's it. So our ping pong example actually does that. It ping on the source chain, pong on the target chain. So that's it. They don't do anything else.
Yeah, I mean that's perfect. Actually, that's exactly what I was talking about. Because like having like an event emission on the target chain, like could be potentially VeChain, for example, where you know, I don't know, something happens and you just emit an event on Ethereum and it causes a kind of reactionary event to occur, or like some other smart contract to be triggered outside of the direct bridge connection, just based on a certain message. And then another smart contract could just be watching the bridge contract for a specific event and then react accordingly, right? Like reward someone based on that, for example.
Yeah. I think you can that I think go further on that one. It'd be like a VeChain watcher, VeChain core chain watcher, which means that when smart contract emit an event on the source chain, and then you can say in the VeChain side, you can define an event called event watched, outside event watched, and then when that event is detected through bridge to the export bridge to the target chain, you just need to emit outside event watched with this outside chain ID and then the smart contract of the source chain, so that you know the target the source chain with this chain ID emit this event through this smart contract address, and that will be very helpful. For example, you want, as you mentioned, you want to give reward based on the outside smart contract, you can have a like off-chain subscriber to that event and the outside event thing, and you can search for that, and then you can give reward based on the activities.
Yeah, that's great. Thank you. I had another question actually as well from the community, which was, are there any major like security best practices or something like that that should, outside of general Solidity best practices, that should be considered for like a bridge of some kind?
Yeah, definitely. There are tons of it. Actually, I give a presentation about cross-chain security. I think that if you look at YouTube, there's another one for it for the cross-chain security. Actually, I'm working for I'm the chair of cross-chain interoperability working group for EEA Enterprise Ethereum Alliance. We actually published a paper called cross-chain decentralized security. Decentralizes cross-chain decentralized cross-chain security guideline. Actually, cross-chain security guideline. We also published one called cross-chain security decentralization guideline. Cross-chain security guideline go beyond the single chain security, which is solidity and other things. The cross-chain is more complex because you need to look at the finality of the source chain and also the reliability of the source chain. If the source chain goes down, right, the things bad things can happen, right? And then there's also relayer. How can you trust the relayer? If the relayer get hacked, okay, of course, this one chain take the burden because we are the relayer to relay the message to the target chain. And we need to make sure these layers have redundancy, have security guarantee, and things like you have MPC, multi-party computing, you have a multi-sig, so that even one system get hacked, it still survive, right? And then in coding, it's more complex. We need to also look at what is very easy to say you have 40, 50 lines of code, but every mistake, any error in those smart cards, any lines of error is going to have a kind of terrible impact. Okay, so those are the things that I think important.
Yeah, yeah. Well, thank you for that. I mean, it'd be really interesting to get some links, if possible, to those papers or some other documentation if that exists, and I'll put it in the live stream after, so anyone who's coming past can check that out. I don't actually have any other questions for you, really. Thank you so much for talking us through all this. I certainly learned quite a bit about how this can go. If you guys haven't already taken down those links for those videos, for the extra resources, I'll put them in the description of the video after the fact. Is there is there like a best place other than maybe the just the documentation? Is there anywhere else that we can go to have a look at some other examples of kind of cross-chain implementation or anything like that, Weijia?
Yeah, if you go to first, we have Wanchain GitHub have tons of open source project. You can also always go to Wanchain's GitHub, and here I have two links here because I think these are most important ones. You can always go to these, and if you kind of go one directly upward, you can see other things as well. You can if you want to read more, I think most of hackathon people are very busy. They want to which one is actually okay. But these are the major ones, and you can also go to wanchain.org and to see application. You also go to bridge.wanchain.org, and those have bridges for VeChain as well. If you want to work on a GUI and other things, you can look at these as well. In fact, the second link here has a GUI also. You can actually use some of the GUI code over there as well.
Great. Weijia, thank you so much. I don't want to take up any more of your time. It's been really, really great workshop. Thanks for taking the time to walk us through so much material. Just quickly before we wrap up, guys, if anyone has any questions or needs any extra information, I've put some links already in the description, and I'll add these extra resources after we finish up this live stream for anyone who wants to come and check out that info as well. If you're interested in signing up for the workshop, the workshop for the hackathon, it's starting next Monday and it's running for 2 weeks. You can check that out. There are links in the description below, or you can contact us through VeChain Builders, join the VeChain Builders Telegram to get in touch with us through that channel. Otherwise, that's about it. Weijia, just thank you so much for your time. I really appreciate you taking the time to walk through everything. And yeah, thank you so much. It was really, really good.
Yeah, thank you, Rhys. It's great to talk to your developers in your community. I hope they enjoy it. And if you have any questions, feel free to reach out and ask us questions, maybe through you or through our channel as well, Wanchain or VeChain channel as well. Thank you very much.
Yeah, will do. Thank you so much, and enjoy the rest of your day.
Yeah, thank you. Thank you.